I was actually messing around with this AI music generator the other day,
Mhm.
and it actually composed this pretty catchy tune.
Yeah.
It wasn't Mozart or anything,
Right.
but it really got me thinking.
Yeah.
How do these large language models actually work?
Yeah.
It seems like they're everywhere now,
Mhm.
writing code,
Mhm.
generating art,
It's
even
amazing.
answering our questions in this surprisingly human-like way.
Yeah, it is pretty mind-blowing, isn't it?
Yeah.
What we're seeing is this convergence of some remarkable breakthroughs in artificial intelligence,
Uh,
particularly in how we understand and scale these LLMs.
okay, so scaling,
Mhm.
that's the secret sauce here.
Yeah.
What does that even mean in the context of AI?
Mm,
Is it just a matter of making these models bigger and throwing more computing power at them?
that's a great question.
Yeah.
And you're right, size does matter,
Okay.
but it's not the whole story.
Okay.
Think of it like a recipe.
Right?
You need the right ingredients
Uh-huh.
in the right proportions to create something truly delicious.
All right, I'm intrigued.
Okay.
What are the key ingredients that make an LLM tick?
There are three main ones:
Okay.
model size,
Okay.
dataset size,
Okay.
and computation.
Gotcha.
Model size refers to the number of parameters in the model,
Mm-hmm.
which you can think of like digital brain cells.
Oh, okay.
Dataset size is all about the volume of text data the model learns from its training material, so to speak.
Okay.
And finally, computation refers to the raw processing power
Mm-hmm.
required to train and run these massive models.
So we're talking about models with billions,
Yes.
maybe even trillions of these digital brain cells
Mm-hmm.
crunching through mountains of data.
It's really incredible.
That sounds incredibly complex.
It is complex.
Yeah.
But what's fascinating is that researchers have discovered
Yeah.
some surprisingly predictable patterns
Okay.
in how these ingredients interact.
Okay.
They call these patterns scaling laws.
Scaling laws.
Yes.
Now we're getting to the good stuff.
All right.
Break it down for me.
Essentially, scaling laws reveal that increasing any of those three ingredients,
Okay.
model size,
Mhm.
data set size, or
Hmm.
computation,
Okay.
generally leads to improved performance in the LLM.
So bigger is better.
Well,
Just keep adding more ingredients and we'll end up with an AI genius.
not exactly.
Yeah.
It's not quite that simple.
All right.
While increasing these factors individually does help,
Yeah.
it turns out that the relationship between them
Mhm.
is even more crucial.
Okay, so it's not just about making a giant cake with a ton of everything.
Right,
It's about finding the perfect balance of ingredients.
precisely.
Okay.
And that's where things get really interesting for a long time.
Yeah.
The prevailing assumption was that bigger models always meant better performance.
Yeah.
But then came a groundbreaking research paper called Chinchilla.
Chinchilla.
Yeah.
Sounds cuddly for a groundbreaking research paper.
Right.
Yeah.
But trust me, this research really shook things up in the AI world.
Okay.
What the Chinchilla paper found
Yeah.
is that by using the same amount of computational power, researchers could achieve significantly better performance
Mm-hmm.
by training a smaller model on a much larger data set.
So it's not just about throwing more computing power at the problem.
Right.
It's about being smart about how you use that power.
Exactly.
Kind of like how a skilled chef can create a culinary masterpiece with simple ingredients.
Exactly. It's about understanding the nuances of these scaling laws
Yeah.
and finding that sweet spot,
Okay.
that optimal balance between model size, data, and computation.
Okay.
This discovery was a game changer.
Yeah.
Researchers realized they didn't necessarily need to build ever larger models.
Right.
Instead, they could focus on optimizing the balance between these key ingredients.
This is where it gets really interesting, right?
Yes.
We're talking about unlocking the true potential of LLMs, finding that Goldilocks zone where everything comes together perfectly.
Absolutely.
Yeah.
It's like having the blueprint to build a more powerful AI.
Okay.
But the challenge now lies in deciphering and applying those instructions effectively.
And that's what researchers are focusing on now,
Yes.
figuring out how to apply these scaling laws to create even more capable and sophisticated LLMs.
You got it.
Wow.
It's a fascinating quest.
Yeah.
And the implications are huge.
Yeah.
Imagine the possibilities if we can unlock the full potential of these models.
Yeah.
But of course, with great power, with great power comes great complexity.
Okay, that's fair.
Yeah.
So what are some of the challenges then that
Right.
researchers are facing as they try to apply these scaling laws
Mm-hmm.
and create even more powerful LLMs?
Yeah, one of the biggest hurdles is simply the sheer scale of these models.
Okay.
We're talking about billions, even trillions of parameters.
Yeah.
Training something that massive requires enormous amounts of data
Right.
and computational resources.
So even if you have a brilliant idea, like based on these scaling laws,
Yeah,
you still need that infrastructure to actually put it to the test.
exactly.
Wow.
We're talking about clusters of specialized computers running for weeks, sometimes even months,
Wow.
just to train a single model.
Goodness.
That kind of computing power isn't exactly easy to come by.
No, it makes you realize that this isn't just a game for like tech giants with deep pockets, right?
Exactly.
It takes a real collaborative effort to push the boundaries of AI research.
Absolutely. Collaboration and open research are more important now than ever. Yeah.
In this field,
Right.
sharing knowledge and resources allows researchers to collectively tackle these challenges
Okay.
and accelerate progress.
That makes a lot of sense.
Yeah.
But let's say for a moment that we do.
Okay.
What if you do have access to all the computing power in the world?
Mm-hmm.
What are some of the other factors that researchers have to consider when training these massive LLMs?
Well, one crucial factor is data quality.
Okay.
It turns out that simply feeding an LLM more and more text data
Yeah.
doesn't necessarily translate to better performance.
Wait, so you're telling me it's not just about quantity, it's about quality too?
That's right.
You can't just throw the entire internet at an LLM
Right.
and expect it to become like a super intelligence?
Think of it this way.
Okay.
Would you rather learn a new subject from a well-written textbook
Right.
or a jumbled mess of random internet comments?
Okay, point taken.
Right.
I'd definitely go for the textbook.
Yeah.
So how do researchers ensure they're using the right kind of data to train these LLMs?
It's all about being selective and strategic.
Okay.
Researchers have found that LLMs trained on high-quality, well-structured data
Okay.
tend to perform significantly better than those trained on random or poorly organized text.
So it's like feeding them a carefully curated diet of information
Exactly.
instead of just letting them loose in a digital buffet.
Exactly. And
Like writing poetry.
yeah, it's fascinating to think that even at this scale, these models still need a bit of guidance,
It's true.
a nudge in the right direction when it comes to the data they're learning from.
It's true. And this brings up another important aspect of LLM development.
Okay.
Understanding the impact of data on the model's behavior and capabilities.
Yeah, I can imagine that's a complex area.
It is.
Because after all, these models learn from the data they're given.
Yes.
So if the data is flawed or biased in some way,
Right.
wouldn't that be reflected in the LLM's output?
That's a very astute observation and a critical area of research.
Okay.
It's essential to ensure that the data used to train LLMs is as representative and unbiased as possible,
Right.
to mitigate the risk of perpetuating harmful stereotypes or biases in the model's output.
So it's not just about making these models bigger and faster.
Right.
It's about making sure they're trained on data that reflects the diversity and complexity of the real world.
Precisely. It's about building AI that's not only powerful, but also responsible, ethical,
Right.
and aligned with human values.
It's starting to feel like we're not just building machines here.
Right.
We're shaping digital minds.
That's an interesting way to think about it.
And with that comes a huge responsibility
Yes.
to ensure we're doing so thoughtfully and ethically.
Yeah.
It's like we're not just writing lines of code here. We're shaping the way these LLMs like see and interact with the world.
Right.
It's a pretty profound responsibility, isn't it?
It really is.
Yeah.
It's a whole new paradigm in technology development.
Right.
Unlike traditional software where you program specific rules, with LLMs, you're essentially creating a learning environment
Yeah.
and then letting the model discover patterns and make connections on its own.
So it's less like programming a calculator
Right.
and more like educating a student.
That's a great way to put it.
Yeah, you're providing the tools and the guidance.
Yeah.
But ultimately, the LLM is responsible for its own growth and development.
Exactly.
Okay, I have to ask.
Yeah.
With all this talk about scaling and data quality
Uh-huh.
and the sheer potential of LLMs,
Right.
where does it all lead?
Okay.
Are we like on the verge of creating some kind of super intelligence
Right.
that surpasses human capabilities?
That's the million-dollar question, isn't it?
Right.
And it's one that sparks a lot of debate in the AI community.
Okay.
Some experts believe that if we continue to scale these models
Mhm.
and refine our training methods,
Yeah.
we could eventually reach a point where LLMs possess a level of general intelligence
Mhm.
comparable to humans.
So the age-old sci-fi dream of creating artificial intelligence that rivals our own
Right.
could actually become a reality.
It's certainly within the realm of possibility.
Wow.
But even if LLMs don't achieve true human-level intelligence,
Okay.
there's no doubt they have the potential to revolutionize countless aspects of our lives.
Yeah.
We're already seeing their impact in fields like customer service, education,
Right.
even healthcare.
It's almost like instead of worrying about AI replacing us,
Right.
we should be thinking about how we can best work with these LLMs,
Exactly.
using them as powerful tools to enhance our own capabilities.
Precisely.
And that's really exciting.
It is really exciting.
This has been an incredible deep dive.
It has.
We've gone from the inner workings of these LLMs
Right.
to the very future of intelligence itself.
It's been a fascinating journey.
It really has.
And it's only just the beginning.
And for our listeners, if you're eager to learn more,
Yes.
I highly recommend checking out the Chinchilla research paper. We mentioned earlier, it's a real eye-opener, even if you're not, a computer scientist.
Absolutely.
But for now, we'll leave you with this thought.
Okay.
If we've come this far in just a few short years, imagine where we'll be in 5, 10, 20 years.
It's incredible to think about.
What role will these AI tools play in your life?
Yeah.
That's something to ponder, isn't it?
It is.
All right, that's it for our deep dive today. Thanks for listening, and we'll catch you in the next one.